All right. Hello, everyone. Welcome to our webinar. My name is Andrew Townsend, and I'm marketing operations here at Smarty. Today's webinar is about managing technical debt, and we're very excited to get started. However, before we do, let's go over a couple bits of the standard housekeeping. First of all, this webinar will be recorded. We will send a copy of it out to everyone who registered, so you'll be able to view that in your email inbox later today. You'll also be able to share that video with anybody that you think may benefit from this. So we'll get that shareable link out to you later today. Second, to interact with our presenters and other audience members, feel free to use the chat and the Q&A features in the Zoom webinar interface. We'll be monitoring that, and I'll bring up some of those questions directly to our presenters throughout the session and during the Q&A at the end. So speaking of our presenters, today we have Kiersten Nelthorpe, one of our software engineer team leads, and Cody Robertson, one of our senior software engineers with us. We're very excited to hear what you guys have to say. So without further ado, Kiersten and Cody.
Thanks, Andrew. So today we're diving into a topic that has significant impact on developers, something we're all familiar with, tech debt, technical debt. Understanding, managing, and communicating technical debt is crucial. It allows us to build better and maintainable software. It allows us to improve our productivity and even boost team morale. So this webinar is intended to provide valuable insight and strategies to help deal with technical debt in our work. So first, we'll talk about the definition of technical debt. Usually I'll just call it tech debt. So tech debt was a metaphor that originated from Ward Cunningham, who's working in financial software. So debt had a lot of impact and meaning to his coworkers and his managers. And it was great for conveying the idea of what we as software developers need to do to keep our code healthy, to keep it in a working state, and the cost of doing quick code, investing early, and then paying that debt later. But the metaphor has expanded. A lot of people use it more broadly today. And so there's largely three sources of technical debt that we'd like to talk about. I'm going to talk about deliberate technical debt that we know we're creating, accidental technical debt that we don't know we're creating, and then tech debt that just accrues over time as software. Our software clearly doesn't change, but the world around it does. So there's a lot of risks and negative impact for technical debt. As debt builds, technical debt or financial debt, either one, as it builds, things start to slow down. It becomes more difficult to pay down the principal. With technical debt, that's our code. It becomes more difficult to change. It becomes more difficult to add new features, to fix bugs, even to just navigate the code. And so if we build up too much technical debt, a team can end up spending all of their time just maintaining the code and have little to no time adding new features. Another big one is decreased code quality. So bugs tend to creep into code that has a large amount of technical debt. It gets easier to miss things as the code gets more complex, as more changes happen, as the code becomes less clean. A great example is one form of technical debt is not writing tests, and bugs can slip through when we don't have our test cases in place. As a team, as a company, as you write code that has more bugs, obviously you lose credibility, and people don't expect your software to work well, or dismiss it entirely and just choose not to use it because it's too difficult, too unreliable. Another big cost is stress on the team, on the personnel, and the morale can go down. I worked at a company that they invested. We intentionally. This was intentional technical debt. We knew we were pushing to get something out. We pushed hard. We cut a lot of corners. Didn't write a lot of tests. And all with the expectation that at the end of the push, we would be able to go back and fix our technical debt. Unfortunately, once you get there, then everybody still wants new features and they want more changes. It can be hard sometimes to pay off that debt once it's accrued. And as that happened, we had people beginning to leave the company. And that is one of the risks, but it further increases the technical debt. People that knew the code and understood what to do and how how to fix things, how to get stuff done, that knowledge is also leaving. So it can be a spiraling problem as technical debt builds. It can rapidly increase. But not all debt is bad. Like financial debt, some technical debt is a good thing. I mean, it's pretty well accepted that if you pay for a trip to Disneyland on consumer debt, that's probably not a good kind of debt. But then it's also well accepted that if you spend money and go into debt to purchase a new piece of equipment that can help your business make money, that's an investment, right? We changed the way we call that. No longer is it a bad debt, but a good one that can help us improve. And so it is with technical debt. When we push hard, often we're pushing forward or cutting corners, creating technical debt so that we can get early feedback. We can get to the product to customers more quickly and learn what is working, what isn't working, what they like, what they don't like. Also, of course, we've got to pay the bills. And so getting something out in a reasonable amount of time. And then once you have revenue, you can hire more developers. You can slow down and fix technical debt and improve the code base and prevent future technical debt.
Yeah, and I have a story to go along with that in terms of really being able to assess your risks of like good debt or bad debt, and really assessing the risks that it could have on your company's reputation. I once was working on a piece of software where I knew there was this tiny bug in it, and we were getting to the end and we really needed to release. There was a deadline that a lot of people were asking for. And I thought, with this one tiny bug, like, what are the chances that anyone's actually going to see this? Because it was one bug out of, it was an educational company. And so it was like, it affected one activity, the reporting on it, out of thousands of activities. And so I was like, what are the chances? And I didn't assess the risks correctly, pushed that code out, and it happened to be the most used activity out of all of them. So it was very apparent. The bug went out. It took a ton of work. Rather than delaying the release by like one day to get that fix out, it took a lot of work on the flip side to like address the bug and then address like the backlash and the hit that we took to our credibility at that point.
Yeah, I think we've all been there before, made mistakes like that. Sometimes it can be hard to estimate and realize what technical debt is going to cost. But I'd like to talk a little bit more about some of the sources and dig into that a little more. We have, like we mentioned, deliberate technical debt. Some examples of that, as we've talked about, skipping tests, not writing unit tests, or appropriately testing all of the code. That's a deliberate decision that we often make as developers. An example is in a proof of concept or a minimum viable product. You're trying to get something out quickly. Code jams is a place, an experience with often skip test or especially skip documentation. You don't even know if the code is going to see the light of day. And it's not necessarily inappropriate to skip documentation and tests, but it is technical debt. Another one, accidental technical debt, right? We talked about that. That looks more like being unfamiliar with the domain we're in, or changing to a new language. We've all experienced learning new things as developers, even in college. You don't exactly know what your language can do, what accepted practices are, or moving from, say, a game developer and you move into financial technology. Those domains are very different. And so the expectations and the common practices in one may not carry over into the other. And so you may create technical debt accidentally, just not knowing what you're getting into. Features are often not well defined at the beginning of a project, or new features come out, are needed to sell the product. And so that's another accidental technical debt. As you go along, you don't know exactly what you're going to face. And so technical debt is created. Another one that at first caught me by surprise is time. Like I said, code doesn't change. We talk about bit rot and things like that, but a lot of code around what we're using does change. Great example is security patches or packages changing their interface. And so you're using a third-party library. It has a security vulnerability. It needs an immediate fix. And often that can create technical debt. We need to go back into our code, maybe change the code, or maybe just update a package. And that takes time, and that is a technical debt that we have to deal with as well. So even if we write perfectly clean code the first time, right, never have any bugs, developers dream, we're still going to end up with some technical debt. So here's a great example. Sometimes the code feels like we're just propping it up. Band-aids abound, they're plenty. And at times that can be okay. You got to keep things running. But if we don't handle it, if we don't pay down our technical debt, then along comes another feature and the whole house of cards comes crashing down. Obviously, that's rare, unwanted, but it can happen. Companies can ignore problems, and before you know it, there's not a company anymore.
Yeah, so let's go over some best practices for tackling that tech debt. So first, you have to reduce your existing tech debt while also minimizing future tech debt so that you're not adding to that, so that you're actually making progress. So in reducing existing tech debt, first you have to identify it, really spend some time with your teams. If you already have a backlog that you're working from, make sure that everything that needs to be addressed is actually noted down in that backlog so that it doesn't fall through the cracks and continue to be a problem over time. Then you need to prioritize by urgency and utility. And going back to the financial debt scenario or metaphor, I guess with financial debt, you can either pay that down. There are a lot of methods. Two of the most popular methods are like the avalanche or the snowball. So now I'm spacing which one's which. I think it's the snowball is paying down your smallest pieces of debt first so that you get that sense of accomplishment and you want to keep going to pay down that debt. And I feel like that can apply really well with tech debt as well. Like pick off some of those small tasks so that you like get a sense of accomplishment and want to continue moving forward. On the other hand, with the avalanche method of paying down financial debt, that's paying down the highest interest rate debt first, because that is the one that in the long term is growing at the fastest rate. So similarly with software, you can choose to bite off those really large pieces that have the largest impact for your team. And luckily, like somewhat different from financial debt, with tech debt, like we usually have teams of developers that we can work with. So you can actually kind of attack those from both ends. Like you can avalanche and snowball at the same time.
You mean you don't have a team of people attacking your financial debt?
I wish. Simultaneously foster a culture of continuous improvement. So gradually fix things in the code as you're naturally working with it. Some developers who are really into test-driven development like to say that every single commit has a test case with it, or every bug fix has a test case alongside of it. You can also think about this if you're trying to pay down a large amount of tech debt in saying that every commit or strive for having every commit or most of those to make the code better. So maybe you're adding a new feature here or fixing a bug, but simultaneously alongside that, try to find somewhere that you can improve the code along the way, refactor something simple. And that's best done when there are test cases so that you aren't breaking things while doing that. If the debt is particularly large, make use of an on-call rotation if your team has that. I once worked on a team a long time ago that had really the whole division had a 10-year bug backlog. So there were literally bugs logged in our backlog that had been logged 10 years prior. And so we had to go through those and see, were they still a problem? Why have they not been fixed for 10 years? And it was so enormous that was why things like that were falling through the cracks.
And to be clear, you did say you said it was a past team,
company.
but also a different company.
Yes, completely different company.
Okay.
10 years ago.
Good clarification.
Yes. Yeah, we'll get into that about the benefits that we've had here at Smarty about tech debt on the end of this. But with that 10-year bug backlog, it was so massive that we ended up making use of our on-call rotation. So developers rotated and they were on call for a week at a time. And anyone who was on call that week If they were not currently addressing like an active customer issue, their job was to go through that bug backlog and the tech debt backlog and like pay those down. Their dedicated job for that week. So if things are really huge, that's also an option. Once you've started tackling your existing debt, and even alongside that, you want to still minimize future debt. Just like with financial debt, if you are accruing debt faster than you're paying it down, that's a big problem. So we need to make sure that it's getting smaller, not bigger and bigger. So embrace code rewrites before merging to main or releasing that code. It's not a bad thing to develop a feature and then realize that it could have been done in a completely different way, and then delete the code and do it again, because the second time around, you're going to develop it much faster. And the time that you spent in the beginning is time that you and the company has paid for your learning and your development so that you can produce good code. Hopefully we don't always have to do that. Like, it's not a whole lot of fun to like delete code all the time and rewrite it. But sometimes that is necessary. And sometimes it actually is the best and fastest way to get good code out there.
What'd you do at work today, honey? I wrote a bunch of code and then I deleted
it. Yeah. We do kind of have like a culture here of really not being afraid of deleting code and redoing it. Hopefully that's usually because we've spent a day or two on something, not like a month writing something and then delete it.
Sure.
That would be way overkill. So, and then plan for time to refactor your code. So if you're estimating how long it's going to take to write a feature, you've got to think about how long it's going to actually write the code. And then it's common for people to think about the time it'll take to write the test cases, and then the time it'll take to hand it over to whoever's releasing the code, if you have an operations team, all of that. But plan for an extra like half day or so, depending on the size of the feature, maybe a full day or more, to go through and refactor and clean up that code before handing it over for release. And that's sometimes the most fun part. And again, test cases there help out a lot. Plan to write flexible code. If you have to make choices in your architecture or designs, err on the side of flexibility so that you can swap out pieces as easily as possible without causing huge rewrites. There are a lot of design patterns that can help with that. Minimize dependencies, because every dependency that you introduce into your system is something that you have to maintain. And so that's maybe one of those pieces of technical debt that like isn't planned, and it's not accidental because it's not like somebody wrote bad code or anything. It's just something that like, it's not an interesting piece of software that, or an interesting piece of our work as software developers, just like maintaining dependencies and things that change as we have to keep those things up to date. So really be deliberate about the dependencies that you introduce into your code.
Yeah, at a place I worked at, we had a problem with that. It was JavaScript, and it was very easy to include new code or third-party libraries, and we did a lot of that. We had a lot of dependencies. It got to the point where we would set aside time at the end of the week, so it didn't completely absorb our time, but we wouldn't even get done upgrading the dependencies in all of our services before we had to start over. Another high vulnerability, an important vulnerability would be in another common package. And it was just a constant. That's all we did with tech debt was updating dependencies. It was not very fun.
Yeah.
So a question I have on this, it seems like, and you kind of mentioned it before, but a lot of these involve time.
Yes.
Taking the time to focus on this and deciding how much time you're going to devote to something isn't always up to the individual developer. It's up to the department, right? Or the culture of the company.
True.
And it sounds like at some of your companies, the culture was either shifting, like yours, Kiersten, where you were saying they were realizing we've got a 10-year backlog. We've got to start shifting to caring about this more.
Right.
And Cody, yours had a culture of, well, we're going to take some time at the end of the week to make these smaller adjustments.
Right.
Maybe you guys are going to talk about this eventually, but do you have any tips or hints on how to change that culture, or how to convey to those powers that be that this is an important thing to focus on?
Yeah, it is important to convey the cost of that tech debt. So any way that you can quantify that. The tricky part is that a lot of it is really difficult to quantify. It's really hard to say, like, this decision cost us so many developer hours in the future, because we don't always know that. We don't know how many developer hours it's going to cost. But we can analyze what's happened in the past, and some of the tech debt that we have already addressed, that we can quantify and say, this decision was made 6 months ago or 9 months ago. And then we had to spend this much time fixing things after the fact. And you can quantify that amount of time looking back in the past. One tool that we actually use here at Smarty quite a bit is a type of meeting called Meet to Learns, where we meet with people from other teams and other departments in the organization, literally just for the purpose of learning about what they do, and learning about what their work is, what their goals are, potentially looking out for ways that we can help them. And it really can give us a good insight into, like, our impact on other teams and other departments in the organization. And I feel like those Meet to Learns can actually go a long way in helping with tech debt, if different people in the company are aware of what people are doing and kind of the impact that their decisions are having on them.
Yeah, I think that's a fantastic question. That is kind of the point of tech debt. The reason we use the metaphor is to help sometimes non-technical people understand that as things progress, we slowly build up debt. And if we don't handle them, they get out of control, just like any debt in our lives. But that it's not always bad. It just requires that effort. And so I think communicating that, and like you say, building a culture around that, or if you already have a culture, it's difficult sometimes to change that, but it's important to continue to convey that the time I'm spending may not be making new features or working on the latest thing, but it's going to help us move more quickly in the future, right? If you're burdened down with so much debt that you just can't get anything done, I think most people understand that, right?
Right. Great.
Yeah,
Thank
totally.
you.
So a couple other ways to minimize future tech debt are, along with being deliberate about minimizing dependencies, like outsource some of the things that you and your team don't need to care about. Because if there are things that you don't need to maintain over time, that's going to free you up to, like, spend time coding the things that you really want to work on. And then you're not, like, unintentionally adding more tech debt for things that you really don't need to care about. One example was we were integrating some internal data into a CRM tool. And at first we thought we were going to write a custom integration and handle it exactly the way we wanted. And then all these things kept changing about the API. Like, all of a sudden they revamped how their authorization was working, and then they changed some other thing. And we, like, every time after our integration was mostly finished at the time, then we had to keep going back and, like, making all these updates. And it was stuff that we just did not care about at all. So we eventually moved on to a third-party tool that just abstracted away all that stuff. And now we don't have to deal with those updates. And the last piece here is sharing knowledge among team members. Having good documentation, of course, we all know about that. Another thing is, if you're working, like, in a microservices architecture or a team that happens to manage multiple code repositories, is it can really help to have a relatively common architecture across those repositories, so that somebody who maybe they haven't worked in, they mostly have worked in A repository and now they're going in to work in B repository, they'll know where to go and the appropriate places to put their code, and they're not going to, like, accidentally make a huge mess of it if there's a common architecture across those. Also, another thing that we are just starting to implement on my team is, at the end of larger projects, I'm asking my team members to do a training for the entire team. And it doesn't have to be long. It could even be like 15 minutes or half an hour, depending on the scope of the project. But that training will address what they developed, why they developed it, where the code was, and some key points on how to maintain that code, so that the rest of the team is aware and they know how to work with that. That, along with reducing tech debt, also reduces silos, and those really go hand in hand. So some of the benefits for us here at Smarty are actually really cool. So like, we don't really have a bug backlog because we have this culture of like focusing on avoiding and minimizing tech debt. That means we're able to address any like live bugs and live issues really fast. And we just like, we don't have a bug backlog at all because anything that comes in, it's like one thing will come in and we get it fixed and it's out the door. So we don't have that constantly hanging over our heads. And that goes a long way in reducing stress for our team members. We don't have an on-call rotation because like things aren't breaking. I think in the last 3 years, I've only had to deal with something like once out of hours. So it really goes to show that being intentional about your technical debt like goes a long way for the happiness and well-being of your team members. And we have reduced silos, like I mentioned. So our team manages around 20 repositories. And for the most part, like anyone on the team can work in any one of them. So those are some of the cool things that we have here.
Yeah, I have to say, I just reiterate what you said. It really is a sort of a breath of fresh air, not to have hundreds of bugs, thousands of bugs just waiting, and you have to find a bug and you go to talk to the person who wrote the ticket and they don't even work here anymore, right? We don't have that at Smarty. It's really great. And there is a definite intentional culture of fixing tech debt and not leaving it for somebody else, leaving it for later. But often when you see it, you do it then. And if then's not the appropriate time, we take time later and do it. It's a priority at Smarty, and it's great. It's a great culture to have.
Totally. In review, an accumulation of technical debt can increase dev time and, sorry, my window is right in front of this, and decrease code quality and employee morale. And I also put a bug in here, tech debt can be either deliberate or accidental, sometimes even unavoidable. Like it will happen. So have those strategies to tackle it when it does. And to tackle it, you need to both address the existing tech debt and minimize future debt. So come at it from both sides. And the benefits of addressing it can be awesome. And speaking of addresses, if you happen to have, hypothetically speaking, because I've definitely never done this in the past, if you happen to have ever been working with addresses, especially for storing addresses associated with orders placed or things like that, and did not standardize them and ended up with some technical debt, when the accountant comes around asking to file sales tax in various states, and then all of a sudden you have to go through and look for all of the addresses in US, USA, United States, and United States with 18 spaces after it. If that's ever happened, we have a wonderful address validation tool that can help take care and clean up of that kind of tech debt.
What a killer segue. That was amazing. That was next level right there. So just to reiterate on there, we have amazing address validation software. We also have, we call it Magical Autocomplete. We just recently started. I haven't told you guys that. We're calling it Magical Autocomplete. Cool. It makes it so that when you get someone that's entering their address on a form, it only takes 3, 4. You can make it so it starts going at 1. The first keystroke, it can start suggesting validated, standardized addresses for them to select. So you can make sure that you're only getting good data into your database. We've also got geocoding tools. We now have a master address list that you can download, all accurate addresses for a certain location. All of these address tools are written by amazing developers like Kiersten and Cody, where we're focusing on reducing that technical debt. So we have very healthy code, and we think you'll enjoy it. So you can grab that if you go to smarty.com/signup or smarty.com, and in the top corner, there's a section to get a free account that comes with 1,000 lookups that you can test with and try out. Our APIs are second to none. Also, coming back to that culture change, culture shift resources, we will be sending out not only a copy of this recording, but we'll include the resources that Cody and Kiersten used to build this deck and gather some of their information. You guys want to talk about a little bit about what's on that sheet?
Sure. Yeah. I mean, we went and looked up, what would you say?
So ChatGPT. Just kidding. Just kidding.
People who know, people who are trusted, Martin Fowler, Uncle Bob, read blogs, videos, and just kind of gathered together our sources to hand out. If you want to do further reading, they go into greater depth and broader detail. And it's just great resource for information about technical debt and how to help build that culture, change the culture of the company.
So we'll send that out so you can have that in your arsenal of convincing people that they need to be focusing on reducing technical debt. Thank you, Kiersten. Thank you, Cody. This has been great. We've used up all of our time. We'll get a copy of this sent out to all of you shortly, and we hope that both of you and all of you in the audience will join future webinars in the future. Thanks, guys.